Hello students, and welcome to the third video of this section. In this video, we're going to look at understanding some trigonometric functions and learning how we find those derivatives. We're going to specifically look at proving why the derivatives we're getting are the way they are. Let's get started. So to start off, I want to kind of do a refresher of two trigonometric identities. In your trigonometry class, you learned about identities. You may not recall these specifically, but we're going to use these to prove some of these identities, or some of these derivatives that we get for sine and cosine. So the first one that you're going to need is cosine of a plus b. So you're going to get cosine a times cosine b minus sine a times sine b. And if you have sine of a plus b, then you're going to get sine a times cosine b plus cosine a times sine b. So they're kind of similar between the two of them, but notice the distinct differences. And so what we're going to do is we're going to use our difference quotient, f of x plus h minus f of x on h. And we're going to use that to find f prime for both sine and cosine. So starting here with sine of x, let me start this out. So the limit as h approaches 0 of sine of x plus h minus sine of x all over h. All right, so let's expand that using that identity that I wrote above. So the limit as h approaches 0 of sine of x cosine of h plus cosine of x sine of h minus sine of x all over h. Okay, so using that identity that I wrote down above, and then from there, I'm going to just kind of rewrite this. So what I'm thinking is I'm going to move this sine of x over here to the left side, and then because I want to combine it with the sine of x that I've got in that first term. So the limit as h approaches 0, sine of x cosine h minus sine of x plus cosine x sine of h all over h. So really just using that commutative property there. And then what I notice in that first set of terms, sine of x cosine h minus sine of x, what I notice there is that they both have a sine of x in common. So I want to factor that out. So the limit as h approaches 0, sine of x, and then what's left over? I get cosine of h minus 1 plus cosine of x sine of h all over h. Okay, so what's going to happen here? I'm going to split up. So I have two terms now in my numerator, and they're separated by addition. So I'm going to make this two different fractions. So let's write out the limit as h approaches 0 of sine of x times cosine h minus 1 all over h plus cosine x sine of h over h. Okay, and what's going to happen with this? So let me scroll down a little bit to get some more space. Well, if you look here, you're going to see some things that you recognize. Cosine of h minus 1 over h and sine of h over h. Well, what happens is when I have this limit here, and we find that limit, we get the limit as h approaches 0 of sine of x times, well, cosine h minus 1 over h is 0 plus cosine of x times 1. Sine of h on h is 1. So what happens is there's nowhere to substitute 0 in here for that limit. Actually, I guess we really shouldn't have that there. That's fine. I can get rid of that because we do evaluate that limit, and that's what we get. And so what's going to happen now, I have sine of x times 0. So I get 0 plus cosine of x. So let's write this out then. So I get f prime of x is equal to cosine of x. So remember, our original function was sine of x. The derivative of that is cosine of x. So now we're going to use the similar method to find the derivative of cosine of x. So let's start out the limit as h approaches 0, a cosine of x plus h minus cosine of x all over h. And then I'm going to expand that using my identity. So the limit as h approaches 0 of cosine of x times cosine of h minus sine of x times sine of h minus cosine of x all over h. And then I'm just going to do a similar thing that I did up here. I'm going to move that negative cosine of x, and I'm going to move it with the other cosine of x in that first part right there. So the limit as h approaches 0 of cosine of x times cosine of h minus cosine of x. I'm just really swapping those two things. Minus sine of x sine of h all over h right there. All right, so very similar thing. I'm going to factor out, but this time I'm going to factor out a cosine of x. So I'll get the limit as h approaches 0, cosine of x times cosine of h minus 1 minus sine x sine h all over h right there. And so again, I'm gonna move this into two separate fractions separated by that subtraction. So limit as h approaches 0, a cosine of x cosine of h minus 1 all over h minus the sine of x times the sine of h all over h. And a similar thing is going to happen. Let me scroll down just a little bit here. So the similar thing is going to happen where those parts are going to evaluate to 0 or 1. So we get cosine of h minus 1 over h, and we get sine of h over h. So let's write this out. When we evaluate that limit, we get cosine of x times 0 minus sine of x times 1. All right? So then I'm going to get 0 minus sine of x, so that my derivative of cosine of x came out to be negative sine of x. So here at the bottom of your page, you're going to see that notation again, d dx, the derivative of sine of x with respect to x. And so d dx of sine of x comes out to be cosine of x. We see that right above it, right there. And then for f prime of x, for when we had cosine, so the derivative of cosine came out to be negative sine of x. So sine was still positive, became cosine, but cosine swapped the sign and it became negative sine. So keep in mind how those are changing as we're going forward. Because as you're going forward, you're going to see the derivative of trig functions very often. So these two that you see behind me here, those two right there, cosine and negative sine of x, those two are going to be very, very important to get down, as well as the 4 other trig functions that you're going to want to get down as well. You're going to see those in a future lesson. So moving forward, you're going to definitely want to know cosine and sine, those derivatives, so that you can do the problems coming ahead. If you do need any help with these 2 proofs about how we're getting our results, do reach out to me. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.